Hi crew, we're going to do a little math review for topic 2 quiz. It's going to be in a couple different parts, so when you're done with this video I want you to do the problems in the form right below before you go on to the next video. We're going to start with mental math for adding and subtraction. We're going to review this idea of compatible numbers. That's when mathematicians look for pairings in their numbers that are easy to combine together. And in class we talked about groups of 10. So immediately I see the 6 and the 4, those add to 10. That could easily combine to make this 20. Then 74 plus 20 is much easier to add mentally, even though I'm writing it out right now. 4 and 0 would be 4, and 7 and 2 would be 9. Now mentally you could do that in your head much easier than adding those three numbers separately. Compensation strategy is a little bit more confusing. Instead of having to borrow for this number, if I just had one more to add in there to make this 30, then this number would be much easier to subtract. 68 take away 30 would be 8 take away 0, I'd have 8, and 6 take away 3, I'd have 3. But remember, we have to compensate for the answer as well. You have to add one more in that answer to make this 39. That's the only tricky part with using compensation strategy. So the next topic we're going to review is rounding whole numbers. And the directions when you will see this on a quiz will say round the whole number to the place of the underlined digit. So in this case, 5 is the rounding digit, and that is in the hundreds place. I would look to the neighbor, which is a 6. And we talked a lot in class about how if this were 5 or above, this 5, the rounding digit, would round up one place value. So this number would become 600. Now realistically you have to look at this. Is this number 569 closer to 500 or closer to 600? And that's how we can know that our answer is a good one. Here we're looking to round to the nearest tens place. Again, I look to the neighbor, and it is above a 5. So this 4, the rounding digit, would round up 1. Now I leave the front digits the same. So it would be 2,350. Notice I changed the last digit to a 0. Now down here, we're in the thousands place. I'd look to the hundreds place. It is below a 5. So I would not be rounding this 5 in the 5,000 place up 1. So this number would stay somewhat the same, 825,000. The rest of the digits would turn to 0. We're going to try this one more time, only this time we're going to be rounding decimals. And in this problem, you're going to, it's really the same, except you have a decimal in the way. So we have to round to the nearest ones place with this 3, and we just look on to the right of the decimal at the tenths place. It is a 5 or above, so this 3 would become 4. Now there's a couple different ways we can write this. We can also include that decimal and say 4.0, which would the same as the other numbers when we turn everything else to zeros. We can also add another 0 on there, but really that's not necessary. In the second example, I'm looking at the 1 in the hundreds place, and I will look to the neighbor. If this is a 5 or above, then I would round that 1 up one digit. Now those front digits need to stay the same. This 0 actually is very important to leave in there. It comes in between the decimal and a digit, so it's very important you don't leave that one off. But this number would then round to 2. And I do not have to change the rest to zeros. I could, if I wanted to, add a 0 on, but it will not change the value. Only when it's between a digit and the decimal will it change the value. In our last example, we're going to look at that 0 in the tenths place, and I'm going to examine the neighbor. Well, it is above a 5, so I'd be rounding that up. Now there's nothing in that place value, so I'd round it up to 1. So I'd leave the front digits the same, 45 and 1/10. Now, I could also put zeros on the end if you'd like. You can also write it that way, 45 and 1/10, but it's not necessary.